Laplace transform. Now, first of all, what is a Laplace transform derivatives? If Laplace of f of t equal to f of s, then Laplace of f dash t we get as f of 0 minus f of 0. And Laplace of f double dash t s square f of 0 minus s f of 0 minus f dash 0. In general, Laplace of f of n raised to n t s raised to n f of s minus s raised to n minus 1 f of 0 s minus s raised to n minus 2 f dash 0 minus f of raised to n minus 1 0. Proof. Taking definition of the Laplace transform, Laplace of f dash t equal to 0 to infinite e raised to minus st f dash t. Integrating by parts, we take e raised to minus st f of t 0 to infinite minus 0 to infinity minus s e raised to minus st f of t dt. Putting a limit in first integral, we get minus f of 0, and for this case s 0 to infinite e raised to minus st, and this is the definition of Laplace transform. So we write as f of 0 minus f of 0. Similarly, for the Laplace of f double dash t equal to minus f dash 0 plus s Laplace of f dash t equal to minus f dash 0 plus s Laplace of f of s minus f of 0. So, we conclude s square f of s minus s f of 0 minus f dash 0. In general, we getting this polynomial form. Now, example of the derivative. Find Laplace of f of t and Laplace of f dash t for this function. First, we are finding Laplace of f of t. What is the Laplace of f of t? E raised to minus 5t sin t. Okay. Step 1. Laplace of sin t 1 upon s square plus 1. But due to in function multiplication is e raised to minus 5t, we are applying first shift theorem. So this is your answer of the f of s. So we find first Laplace of f of t. Now we have to find Laplace of f dash t. What is Laplace of f dash t? It is s f of s minus f of 0. S f of s, that means s plus 5 whole square plus 1. F of 0, we are putting sin t, sin 0, so it is 0. Answer is s upon s plus 5 whole square plus 1. Okay. Next example. Find Laplace of f dash t where f of t equal to 3 and 0 and limit of t is for the 3 0 to t 0 to 5 and t greater than 5. First of all, we have to find Laplace of f of t, and that is we have to find using definition of Laplace transform. E raised to minus st f of t dt 0 to 5 3 e raised to minus st dt. So it is 3 e raised to minus st upon minus s 0 to 5. So it is e raised to minus 5s upon minus s plus 1 upon s 3 multiplication. So we get 3 by s 1 minus e raised to minus 5s. Now we have to find Laplace of f dash t. Formula is as f of s minus f of 0. For the s, 3 by s 1 minus e raised to minus 5s. Now we are putting t0. If we are putting f of t equal to 0, so we get it is 0. Because t is less than or equal to 0 formation, it's give our answer as a 3. So 3, 1 minus e raised to minus 5s minus 1. Answer is minus 3e minus 5s. Okay. Next, Laplace transform of integrals. If Laplace of f of t equal to f of s, then Laplace of integration 0 to t f of t is f of s by s. Proof of this theorem: integration 0 to t f of t dt. We are taking this integral directly as a f of t formation, 0 to infinite e raised to minus st. This is the definition of the Laplace transform. And integrating by parts, we get 0 to infinite 1 by s e raised to minus st f of t dt. So answer is f of s by s. Now, next example is integration 0 to t e raised to t sin t by t dt. Here we have to compulsory follow the order of the formula. First, we have 0 to t e raised to t sin t by t. Okay, dt. Now, step 1. First is original function. What is original function? Laplace of f of t, Laplace of sin t. What is the Laplace of sin t? It is 1 upon s square plus 1. Next is sin t by t. Sin t by t. So, division by t, we are integrate s to infinity 1 upon s square plus 1 ds. So we get Laplace of sin t by t. It is your step 2. Tan inverse s to infinite. So answer is cot inverse s. Step 3. Find Laplace of e raised to t sin t by t. So cot inverse s to s minus 1. So answer is cot inverse s minus 1. Now last step, Laplace of integral 0 to t e raised to t sin t by t dt. So answer is cot inverse s minus 1 upon s. Due to integral, we are divided by s. So this is your answer. Revise this. Find Laplace transform for integration 0 to t e raised to t sin t by t dt. So first we have to find Laplace of sin t then division by t rule, then first shifting theorem, and then applying integral rule. So your answer is cot inverse s minus 1 by s. Next example, find Laplace transform of integration 0 to t sin a t dt. Step 1, find Laplace of sin a t. It is a upon s square plus a square. Due to two-time integral, we are dividing 2 times s square, and this is your answer.